April 13th, 2029. Friday the 13th, because of course it is. At exactly 2146 UTC, a 370-meter-wide mountain named after the Egyptian god of chaos will pass Earth at 75,000 miles per hour. It will come closer to your head than the satellites beaming this video to your screen. This thing is bigger than the Empire State Building. If it hit Earth, which it won't, probably, it would release 1,200 megatons of energy. That's 80,000 times the bomb that destroyed Hiroshima. For about 12 hours, it will be visible to the naked eye. 2 billion people will look up and see death floating by, waving at us like, not today, but maybe later. June 19, 2004. Kitt Peak National Observatory, Arizona. 2 astronomers discover a new asteroid. They run the orbital calculations. Then they run them again. Then they call NASA. Initial calculation, 2.7% chance of impact on April 13, 2029. 2.7% doesn't sound like much until you realize those are better odds than winning $100 on a scratch-off ticket. And you've bought those, haven't you? For 48 hours in December 2004, scientists genuinely thought this might be it. The big one, the asteroid that resets civilization. NASA quietly started making phone calls. Governments started making plans. Then they got better data. Recalculated, no impact in 2029. But here's the fun part, and by fun I mean terrifying. Apophis isn't done with us. After 2029, it comes back. Again, and again, and again. 2036, it'll be back. 2068, hello again. 2116, still visiting. It's like a cosmic stalker that keeps walking past Earth's house, getting closer each time, testing our defenses, waiting for us to let our guard down. I'm not going to hit you, says the mountain-sized space rock, traveling at 20 times the speed of sound. I'm just going to pass so close that your gravity will literally change my orbit. Trust me. Right now, teams of scientists are tracking this thing 24/7. Not because they think it'll hit us in 2029, they're 99.9999% sure it won't. It's that 0.00001% that keeps them up at night. Because at 75,000 miles per hour, by the time you realize the calculations are wrong, you have about 4 hours to say goodbye. Welcome to the story of humanity's closest encounter with cosmic deletion. And the insane part? This isn't even the biggest thing that's buzzed our planet. It's just the one we know about.
June 19th, 2004. Kitt Peak National Observatory, Arizona. Roy Tucker, David Tholen, and Fabrizio Bernardi are doing what astronomers do, looking for things that could kill us all. They're part of the University of Hawaii Asteroid Survey, funded by NASA to find near-Earth objects. Their job? Find the rocks before the rocks find us. At 9:47 p.m., they spot a faint dot moving against the background stars. They designate it 2004 MN4. Boring name for something that would soon terrify the entire planetary defense community. For 6 months, it's just another space rock. There are 30,000 of them buzzing around Earth. What's one more? December 20th, 2004. Someone runs the orbital calculations with updated observations. Oh no. The Torino scale incident. The Torino scale measures asteroid threat level from 0 to 10. 0, no threat. 1, worth watching. 5, serious threat. 10, goodbye civilization. On December 23, 2004, Apophis hits level 2. December 27, level 4. Level 4, the first asteroid ever to reach level 4. NASA's official statement, no need to panic. NASA's internal emails, holy shit, holy shit, holy shit. What a 2.7% chance really means. Let me put this in perspective. Chance of dying in a car crash, 1%. Chance of being struck by lightning, 0.00065%. Chance of winning Powerball, 0.00003%. Chance of Apophis hitting Earth, 2004 calculation, 2.7%. If your doctor said you had a 2.7% chance of dying next Friday, you'd be writing your will. The 48 hours of panic. December 24th to 26th. While everyone's celebrating Christmas, a small group of scientists are calculating the end of the world. NASA doesn't immediately go public. Why? Because telling people there's a small chance you'll die in 25 years on Christmas seems rude. Merry Christmas! Also, mark your calendar for potential extinction in 2019. Pass the eggnog. December 27th, 2004. Arecibo Observatory in Puerto Rico aims its massive radar at Apophis. Better data comes in. Recalculate, chance of impact drops to 0.004%. December 28th, basically zero. Scientists, false alarm. Public, what alarm? You didn't tell us. Scientists, exactly. You're welcome. Why Apophis? Originally called 2004 MN4, it needed a real name. The discoverers chose Apophis. Apophis, ancient Egyptian god of chaos, darkness, and destruction, enemy of Ra, tries to swallow the sun every night. Let's name the asteroid that might kill us after a god of destruction. Isn't that tempting fate? It's ironic. I don't think the asteroid understands irony. Fun fact, the discoverers were fans of Stargate SG-1, where Apophis was the main villain. So, Earth's potential destroyer is named after a TV show bad guy. Apophis, the stats. Diameter, 370 meters, 1,214 feet. Mass, 61 million tons. Composition, rocky, probably iron nickel. Rotation, tumbles chaotically every 30 hours. Speed, 30.7 kilometers per second relative to Earth. Orbit, 324 days. Crosses Earth's path twice yearly. If it hit Earth, energy, 1,200 megatons TNT equivalent. Crater, 5 kilometers wide. Destruction radius, 100 plus kilometers. Deaths if hits populated area, millions. Deaths if it hits ocean, still millions. Tsunamis. It's not a planet killer, it's just a city deleter, or a small country ender, or a coastline eraser. Very comforting. Tracking the beast. Since 2004, Apophis has been observed, 4,000 plus optical observations, 20 plus radar observations, 5 space telescope observations, constant monitoring when visible. Every observation refines the orbit. Every refinement changes the odds. 2004, 2.7% chance of impact. 2005, 0.004%. 2006, 0.001%. 2013, 0%. 2021, 0% for 100 years plus. So we're safe. Yes. You're sure? 99.999% sure. So there's a chance. Yes. The gravitational keyhole problem. Here's the terrifying part. In 2029, Earth's gravity will change Apophis' orbit. If it passes through a very specific region, a gravitational keyhole just 600 meters wide, it'll be set on a collision course for 2036. 600 meters. That's the difference between cool light show and civilization-ending event. NASA in 2004. We need to know exactly where it will pass. Also NASA, our measurements have a 1,000-meter margin of error. Everyone, that seems problematic.
Let me walk you through exactly what's going to happen on April 13th, 2029. And I mean exactly, because NASA has calculated this down to the second. T-minus 24 hours, April 12th, 2029. Apophis becomes visible to small telescopes. Location, coming from the direction of the sun. Amateur astronomers, there it is. Everyone else, where? I don't see. Oh my God! Every telescope on Earth points at Apophis. Every news channel goes 24/7 coverage. CNN, breaking, asteroid still not going to hit us. Fox News, is the asteroid liberal? Twitter, Apophis is canceled for almost killing us.
T-minus 12 hours. Apophis becomes visible with binoculars. Stock markets, volatile. Religious groups, it's a sign. Scientists, it's literally just physics. Conspiracy theorists, the government is hiding something. What governments are actually doing? Emergency services on standby, just in case. Satellites being moved, it's passing through their orbit. Aircraft redirected, paranoia. Nuclear bunkers, quietly staffed, more paranoia. T-minus 6 hours. Apophis visible to naked eye. Appears as a moving star. Brightness magnitude 3.1, as bright as stars in the Big Dipper. 2 billion people can see it without equipment. The entire population of Europe, Africa, and Asia look up simultaneously. Instagram crashes from asteroid selfies. The apocalypse is postponed while everyone finds the right filter. T-minus 0, the moment of truth. April 13th, 2029, 2146 UTC. Distance, 31,086 kilometers, or 19,117 miles. That's closer than geostationary satellites, 35,786 kilometers. It's 1/10 the distance to the moon. It's so close, Earth's gravity bends its path by 28 degrees. Speed as it passes, 7.42 kilometers per second relative to Earth. Visibility, moving across the sky fast enough to see motion. Time visible, 2 to 3 hours at peak brightness. Width of sky covered, 40 degrees, the width of your fist at arm's length. What you'll see from New York, passes overhead at 5:46 p.m. local time. London, low on the western horizon at 10:46 p.m. Tokyo, morning of April 14th, eastern sky. Sydney, not visible, sorry, wrong hemisphere. The satellite graveyard problem. Apophis passes through the zone where our communication satellites live. Satellites at risk, 400 plus. Satellite operators, should we move them? Insurance companies, definitely move them. Satellite fuel, limited. Decision, move the expensive ones, pray for the rest. Your Netflix might buffer for a few hours while we dodge an asteroid. First world problems during near extinction events. Earth changes Apophis forever. As Apophis passes, Earth's gravity speeds it up by 0.7 kilometers per second, bends its orbit by 28 degrees, changes its orbital period from 324 to 378, shifts its future path unpredictably. This is called a gravitational slingshot. We're literally playing cosmic billiards with a mountain. Apophis gets shaken. Earth doesn't just change Apophis's orbit. Our gravity literally shakes it. Tidal forces stress the asteroid, possible landslides on its surface. Rotation rate changes, might crack or deform. We're giving a space mountain an earthquake. What could possibly go wrong? The greatest asteroid study in history. Every space agency prepares 100 plus ground telescopes, 10 plus space telescopes, radar installations worldwide, possible spacecraft flyby mission. We'll learn more about asteroids in one day than the previous century. Data collected, exact composition, internal structure, rotation changes, surface features, gravity field, future trajectory, crucial. The human chaos. Doomsday cults, the end is nigh. Reality, it literally isn't. Asteroid parties like eclipse parties but weirder, expected attendance, millions, alcohol sales, record-breaking. Religious groups claim significance. Scientists, it's just orbital mechanics. Religions, God works through orbital mechanics. Insurance claims for anxiety, insurance companies, anxiety isn't covered. Lawyers, it is now. Humans watching death float by while drinking beer and taking selfies. We're either incredibly brave or incredibly stupid. The April 13th economy. Tourism to visibility zones, $10 billion. Telescope sales, sold out globally. Asteroid insurance, $2 billion. Scams. Emergency supplies. $5 billion. Unnecessary. Global productivity loss. $50 billion. Everyone watching. Total economic impact. $100 billion for something that won't hit us. April 14th, 2029. The morning after. Apophis recedes into darkness. Earth still alive. Humanity embarrassed about panicking. Scientists, we told you it would miss. Public, but what about next time?
Now let's talk about the nightmare scenario. What if the calculations are wrong? What if there's an undetected companion asteroid that changes its trajectory? What if Apophis hits Earth? Disclaimer, this won't happen in 2029. Probably. Almost certainly. 99.999% won't happen. But that 0.001%? Why are you scaring us with something that won't happen? Because it could happen with the next asteroid. When? Tonight? Tomorrow? In 100 years? We don't know. That's the point. Where it hits matters. Earth is 71% water, so probably ocean impact. But let's explore all possibilities. Scenario 1. Ocean impact, Pacific. Impact energy, 1,200 megatons. Crater in the ocean floor, 5 kilometers wide. Water displaced, 5 cubic kilometers. Tsunami height at impact, 200 meters. Tsunami height 1,000 kilometers away, 10 meters. Tsunami height at coastlines, 5 to 50 meters. Time to reach, Hawaii, 1 hour. Japan, 3 hours. California, 5 hours. Chile, 8 hours. Death toll, 10 to 50 million. Economic damage, $10 trillion. Recovery time, 20 plus years. At least it's just a tsunami. Just a tsunami? Could be worse. Could hit land. Dot. Scenario 2. Land impact. Major city. Let's say Los Angeles, because Hollywood loves destroying LA. Ground zero, complete vaporization, 10-kilometer radius. Fireball, everything burns, 30-kilometer radius. Blast wave, everything flattened, 100-kilometer radius. Earthquake, magnitude 7.5. Ejecta, rocks raining down, 500-kilometer radius. Immediate deaths, 5 million. Injured, 10 million. Displaced, 20 million. Economic damage, $20 trillion. The aftermath. Dust in the atmosphere blocks sunlight. Global temperature drop, 2 degrees Celsius for 2 years. Crop failures worldwide. Famine, 100 plus million at risk. Civilization collapse, possible. So we survived the impact. Yes, now you get to starve in the dark. Yay! Scenario 3, the Yellowstone nightmare. What if it hits Yellowstone? You know, the supervolcano. Impact triggers eruption, possible. Volcanic explosivity index, 8, super eruption. Ash coverage, half of North America. Global volcanic winter, 10 plus years. Deaths, 100 plus million. Civilization, probably done. What are the odds of hitting Yellowstone? Tiny. But not zero? Nothing is ever zero. I hate statistics. It happened before. Tunguska, 1908. 50-meter asteroid. Flattened 2,000 square kilometers of forest. If hit London, 7 million dead. If hit today's London, 15 million dead. Chelyabinsk, 2013. 20-meter asteroid. 1,500 injuries from broken glass. No warning, came from the sun's direction. We found out when it exploded. Chicxulub, 66 million years ago. 10-kilometer asteroid. Killed the dinosaurs, 75% of species extinct. Mammals inherited the Earth. You exist because of this impact. Asteroids killed the dinosaurs but created us? Yes. So they're good? Well, you won't think that when one's heading for your house. The ones we don't see. We found 90% of civilization-ending asteroids, 1 kilometer plus. We found 40% of city killers, 140 meters plus. We found 1% of Tunguska-sized, 50 meters plus. We found 0.1% of Chelyabinsk-sized, 20 meters plus. There are millions we haven't found.
Coming from the sun? Invisible until impact. Dark asteroids? Nearly undetectable. Interstellar visitors? No warning at all. So we're tracking Apophis obsessively while thousands of unknown asteroids could hit us tomorrow? Correct. That's terrifying. Welcome to astronomy. If we had 24 hours warning. Hour 1, detection and verification. Hour 2, calculate impact location. Hour 3, alert governments. Hour 4, public announcement. Hours 5 through 8, mass panic. Hours 9 through 16, evacuation attempts. Hours 17 through 20, infrastructure collapse. Hours 21 through 23, final preparations. Hour 24, impact. Evacuation reality. Need to move, 10 plus million people. Road capacity, 100,000 per hour. Time needed, 100 plus hours. Time available, 20 hours. Result, most don't make it. The evacuation plan is basically good luck, everyone.
So, how do we stop an asteroid? Hollywood has ideas. Scientists have different ideas. Let's explore why Bruce Willis can't save us. Hollywood solutions that don't work. Nuclear bombs, just blow it up. Reality creates multiple impacts instead of one. Result, death by shotgun instead of rifle. Drilling and nuking, Armageddon style. Reality can't drill in zero gravity. Also, nuclear bombs need atmosphere to work properly. Also, Bruce Willis is 69 years old. Lasers, Star Wars style. Reality would take years to heat asteroid enough. Power requirement more than Earth produces. Hollywood lied to us. Hollywood thinks sound travels in space. Fair point. Actual planetary defense options. 1. Kinetic impactor. NASA already did this. September 2022 DART mission slammed spacecraft into asteroid Dimorphos, changed its orbit by 33 minutes. Cost? $330 million. Success? It worked. For Apophis? Need 10 plus years warning, send 20 plus impactors, change velocity by 1 centimeter per second, miss Earth by 50,000 kilometers. We're going to headbutt the asteroid away? Basically, yes. That's the plan. It worked on Dimorphos. Dimorphos wasn't heading for Earth. Details. 2. Gravity tractor. Park spacecraft near asteroid, use gravity to slowly pull it. Time needed? 20 plus years. Fuel needed? Tons. Success rate? Theoretical. It's like moving a mountain with a magnet the size of a penny from 50 feet away, while both are moving at 70,000 miles per hour. 3. Nuclear deflection, not explosion. Detonate nuke near asteroid, not on it. X-rays vaporize surface, vaporized material acts as thrust, changes trajectory slightly, need 5 to 10 years warning. So we're going to nuke it? Near it. What's the difference? About 50,000 kilometers between missing Earth and hitting it. 4. Solar sails. Attach giant mirror to asteroid. Use sunlight pressure to push. Time needed? 50 plus years. Technology readiness? Not even close. 5. Paint it white. I'm not joking, this is real. White surface reflects more sunlight, changes thermal properties, creates tiny thrust, the Yarkovsky effect. Time needed? 100 plus years. Our plan is to paint the asteroid. It's scientifically sound. We're going to die, aren't we? Probably not from this specific asteroid. Who's in charge of not dying? NASA Planetary Defense Coordination Office. Budget $150 million a year. Staff 12 people. Responsibility? Saving 8 billion people. 12 people. The fate of humanity rests on fewer people than work at a McDonald's. ESA Space Situational Awareness. Budget $55 million a year. Staff 8 people. Plan? Hope NASA handles it. UN Office for Outer Space Affairs. Budget $2 million a year. Authority? None. Plan? Write strongly worded letters to asteroids. The Watchers. Catalina Sky Survey finds 45% of near-Earth asteroids. Location? Arizona. Budget $1 million a year. Staff 8 people.
Pan-STARRS, Panoramic Survey Telescope. Location, Hawaii. Discoveries, 6,000 plus asteroids. Problem, only covers 75% of the sky. Atlas, Asteroid Terrestrial Impact Last Alert System. Warning time, 1 week for 45-meter asteroid. Warning time, 3 weeks for 120-meter asteroid. Warning time, hopefully enough to say goodbye. Missions in development, NEO Surveyor, launch 2028, Infrared Space Telescope, find 90% of dangerous asteroids, cost $1.2 billion. Congress says, that seems expensive. Scientists, how much is civilization worth? China's Asteroid Deflection Mission 2030, target 2019 VL5. Plan, kinetic impact. Secret plan, probably mining. Hera, ESA, launch 2024, study DART impact site. See if we actually changed anything, or made it worse. What if deflection makes it worse? Then we try something else. When? Next asteroid. How much warning do we need? 1 day? Prayer. 1 week? Evacuation? Poorly. 1 month? Evacuation? Better. 1 year? Last-minute deflection attempt. 5 years? Kinetic impactor. 10 years? Multiple options. 20 years? Comfortable deflection. 50 years? Could paint it white. The real challenge? Humans. Scenario? Asteroid heading for China. China? Will nuke it. USA? That might make it hit us. Russia? Or us. UN? Let's form a committee. Asteroid doesn't care about politics. The asteroid is 6 months away. What do? Blame the other political party. That's not helpful. It's what we're good at.
You know what humans do when faced with potential extinction? We monetize it. Let's talk about the Apophis economy. Yes, that's a thing. The insurance nightmare. Lloyd's of London offers asteroid insurance. Premium, $100,000 per year. Coverage, $10 million. Deductible, $1 million. Fine print, doesn't cover acts of Apophis. You sell asteroid insurance that doesn't cover asteroids? We cover asteroid damage. What's the difference? About $10 million in payouts. Apophis market volatility. Every Apophis news story. New calculations show. Market drops 2%. NASA confirms safe pass. Market rises 1%. But what about 2068? Market drops 3%. 2068 also safe. Market shrugs. Apophis-related trading, $50 billion annually. Actual Apophis risk, essentially zero. Trader profits from fear, essentially infinite. Disaster Tourism 2029. Apophis Experience Package, $50,000. First-class flight to optimal viewing location, 5-star hotel for Asteroid Week, high-powered telescope rental, I Survived Apophis 2029 t-shirt. Therapy sessions included. Expected tourists, 5 million. Revenue, $250 billion. Actual danger? None. Instagram posts? Infinite. Pay $50,000 to watch something not hit Earth. People pay to see eclipses. Eclipses don't have a 0.0001% chance of killing everyone. That's what makes it exciting. The Research Gold Rush. Pre-Apophis asteroid research funding, $50 million per year. Post-Apophis, $500 million per year. Number of new asteroid experts, 10,000. Number of actual asteroid experts, 100. Every university suddenly has an asteroid studies program. Every PhD student, my thesis is on Apophis. Every grant proposal, relevant to Apophis defense. The Apophis Media Complex. Discovery Channel, Apophis Week every April. Netflix, 47 Apophis documentaries. Hollywood, 12 Apophis movies in production. Publishing, 2,000 plus Apophis books on Amazon. Apophis the Musical, Broadway, 2028. Apophis on Ice, because why not? The Real Housewives of Apophis somehow exists. We turn potential extinction into entertainment. That's the most human thing ever. Should we be proud or ashamed? Yes. The military-industrial asteroid complex. Defense contractors pivoting to planetary defense.
Lockheed Martin, $2 billion in asteroid contracts. Boeing, $1.5 billion. Northrop Grumman, $1 billion. SpaceX, we'll do it for half price. Weapons designed for asteroids, but really for war. Asteroid interceptor missiles, ICMBs, planetary defense lasers, space weapons, kinetic deflection systems, orbital bombardment. These are for asteroids, right? Absolutely. Not for other countries? Would we lie? Constantly. Apophis coin and other scams. Apophis coin, the official cryptocurrency of survival. Market cap, $500 million. Actual value, 0. Investors, somehow thousands. Asteroid NFTs, own a piece of Apophis. Sales, $50 million. Legal ownership, none. Buyers, still confused. Apophis safe zones, real estate scam. Guaranteed asteroid safe property. Location, literally anywhere. It's not hitting. Markup, 500%. The actual benefits. Increased asteroid detection, 500% improvement. New deflection technologies, actually developed. International cooperation, slightly better. Public awareness, dramatically increased. Science funding, finally adequate. So, Apophis is good for us? The fear of Apophis is good for science. That's depressing. Welcome to human psychology. Gambling on extinction. Vegas odds on Apophis impact, 2029, 1 million to 1 odds. 2036, 500,000 to 1 odds. 2068, 100,000 to 1 odds. Ever, 1,000 to 1 odds. Total bets placed, $100 million. Bookie profit, 100%, if no impact. Bookie profit of impact, who cares? We're dead. You can bet on the apocalypse. You can bet on anything in Vegas. What if you win? You collect your winnings in the afterlife.
While everyone's obsessing over Apophis, there are 30,000 other near-Earth asteroids playing cosmic pinball with our planet. Let's meet the rocks that could kill us while we're distracted by Apophis. The Rogues Gallery. Bennu, the Sampler. Size, 490 meters. Impact probability, 1 in 2,700 by 2182. Fun fact, we already visited and took samples. Terrifying fact, it's a rubble pile held together by static. We visited it? OSIRIS-REx brought back samples in 2023. So we poked the thing that might kill us? For science. 2010 RF-12, the Frequent Flyer. Size, 7 meters, bus-sized. Passes Earth every year. Closest approach, 79,000 kilometers, 2022. Eventually, we'll hit Earth. When? Nobody knows. 1950 DA, the Long Game. Size, 1.3 kilometers. Impact date, March 16, 2880. Probability, 1 in 300. Solution, let our descendants handle it. That's 856 years away. Yes. Why worry now? Because compound interest on prevention is cheaper than last-minute panic. The ones we don't know about. Estimated undiscovered city killers, 15,000. Estimated undiscovered regional destroyers, 1,000. Estimated civilization enders, maybe 10. Chance we'll find them before impact? Shrum. Discovery rate, 1,000 per year. New dangerous ones, 30 per year. Ones that disappear after discovery, 50 per year. They disappear? Lost in space. How do you lose an asteroid? Space is big, asteroids are small, math is hard. The Tourists from Hell. Oumuamua, 2017. First confirmed interstellar object. Speed, 87.3 kilometers per second. Warning time if aimed at Earth, 3 months. Shape, weirdly elongated. Conspiracy theories? It's aliens. It's not. Borisov, 2019. Second interstellar visitor. Speed, 32 kilometers per second. Composition, surprisingly normal. Message, other solar systems throw rocks too. So asteroids from other solar systems can hit us?
Yes. With no warning? Minimal warning. And they're traveling faster? Much faster. Great. Space hates us. The big boys still out there. 29075, 1950 DA, the spinner. Size 1.3 kilometers. Rotation once every 2.1 hours. So fast it should fly apart. Held together by van der Waals forces or dark magic. Scientists aren't sure. 99,942 Apophis. Wait, we covered this. Still terrifying. Still coming. Still probably missing. Probably. 4179 Tsunamis, the drunk driver. Size 4.5 kilometers. Rotation, chaotic tumbling. Passes Earth every 4 years. Trajectory, unpredictable long-term. Asteroid threat levels. Potentially hazardous asteroids, PHAs. Definition, 140 meters, passes within 0.05 AU. Currently tracked, 2,300. Actual threats, maybe 20. Panic level, constant. Near-Earth asteroids. Currently tracked, 30,000. New discoveries, 3 per day. Lost after discovery, 1 per week. We find 3 and lose 1? Net gain of 2. That's not reassuring. It's better than net loss. How often Earth gets hit? Daily, 100 tons of dust and tiny meteorites. Monthly, car-sized object, burns up. Yearly, bus-sized object, mostly burns up. Decade, house-sized object, Chelyabinsk. Century, football-sized object, Tunguska. Millennium, Apophis-sized, regional devastation. Million years, kilometer-sized, civilization reset. 100 million years, 10-kilometer plus, mass extinction. We're overdue for a Tunguska. We're way overdue for an Apophis. Overdue? Statistically. Statistics can't be overdue. Tell that to Yellowstone.
After Apophis passes in 2029, everything changes. Not because of what happens, but because of what doesn't happen. We'll have looked death in the eye, blinked, and realized we've been playing cosmic Russian roulette this whole time. The immediate aftermath 2029 to 2030. April 14th, 2029, Apophis recedes. April 15th, Apophis 2036 trends on Twitter. April 16th, funding for asteroid defense increases 1,000%. May 2019, every country announces asteroid defense program. June 2019, Space Force becomes relevant. The new space race. Not for exploration, for survival. USA, Planetary Defense Shield, $100 billion. China, Heavenly Shield, $80 billion, claimed. Russia, Space Guard, $30 billion, claimed. EU, Asteroid Defense Initiative, 50 billion euros. India, Space Shakti, $20 billion. Everyone's building the same thing. Detection systems, deflection capabilities, bunkers, just in case. We're militarizing space to fight rocks. Better than fighting each other. Are we, though? No, we're doing both. The convenient overlap. Asteroid defense technology equals asteroid mining technology. We're building this to save Earth. Equals we're building this to get rich. By 2040, every asteroid deflection mission also prospects. Every mining mission claims defense purposes. Nobody knows who's doing what. Everyone's suspicious of everyone. What we'll build? Lunar Asteroid Watch Station, 2035. Far side of Moon, no Earth interference, sees asteroids Earth can't, staffed by people who really lost the job lottery. Lagrange Point Defense Platforms, 2038. Stationed at Earth Moon L4 and L5, nuclear deflection capability, definitely not weapons platforms, definitely weapons platforms. The Asteroid Highway, 2040. Regular missions to near-Earth asteroids. Map everything. Tag dangerous ones. Mine valuable ones.
accidentally create more dangerous ones. We're going to accidentally create threats? Moving asteroids from mining might send others towards Earth. That seems counterproductive. Welcome to human problem solving. How society changes. Education, asteroid drills replace fire drills. Everyone under your desks. That won't help with an asteroid. It's for psychological comfort. Religion, new apocalypse narratives. God will send an asteroid. Which one? The one science doesn't see coming. Insurance, mandatory asteroid coverage. Premium, $100 a month. Payout if asteroid hits. $0, you're dead. Insurance company profit, $100 a month. Dating apps, asteroid preparedness becomes attractive. Looking for someone to watch Apophis return with in 2036. Must-have bunker. The 100-year plan. 2050, complete asteroid catalog, 99.9%. 2060, deflection systems fully operational. 2070, Mars base for asteroid monitoring. 2080, asteroid capture and parking. 2090, routine asteroid harvesting. 2100, asteroids become resources, not threats. So we solve the asteroid problem by 2100? We turn the problem into profit. That's the most human solution possible. We're consistent. What Apophis teaches us. 1, we're not special. Universe tries to kill us regularly. 2, we're incredibly lucky, haven't died yet. 3, we're incredibly stupid, just started looking. 4, we're incredibly capable, can actually stop them. 5, we're probably still doomed, but not from asteroids. When Apophis comes back, 2036, distance, 8 million kilometers, comfortable. 2051, 15 million kilometers, boring. 2066, 3 million kilometers, interesting. 2068, unknown, concerning. 2116, let our grandkids deal with it. Each pass changes its orbit. Each change creates uncertainty. Eventually, statistics say impact. When? Nobody knows.
On April 13, 2029, 2 billion people will look up and see death pass by at 75,000 miles per hour. It won't hit us this time. But Apophis isn't the villain in this story. It's the alarm clock, the cosmic reminder that Earth exists in a shooting gallery, and we've been sleepwalking through it for 4.5 billion years. Right now, as you watch this, there are 30,000 track asteroids, millions of untracked ones, infinite time for one to find us, and finite time to prepare. We spent more money making movies about asteroids than detecting actual asteroids. We know more about fictional space rocks than real ones. That's either hilarious or terrifying. Probably both. In 1,641 days, Apophis will pass closer to Earth than your TV satellites. You'll be able to see it with your naked eyes, a mountain-sized reminder that the universe doesn't care about your mortgage, your politics, or your TikTok followers. But here's the beautiful thing. We saw it coming. We calculated its path. We prepared for it. We'll watch it pass, raise a glass to our continued existence, and get back to arguing about meaningless things. Because that's what humans do. We stare into the cosmic void, flip it off, and go back to living. Apophis will be back. So will other asteroids. Bigger ones, closer ones, ones we haven't found yet. But now we're watching. Now we're ready. Now we know. The dinosaurs had 165 million years and died looking up at the sky in confusion. We've had 300,000 years and built telescopes. Let's see who lasts longer.